Welcome to this channel. In this video, we are going to be looking at some practice questions on complex numbers, Maths 101. So the first question is, what's the value of I raised to the power 5,234? So the first thing to know here is that the value of I is equal to the square root of minus 1. And the value of I squared, right, will give us what? Minus 1. The square root of minus 1 times square root of minus 1 is what? Minus 1. Because remember, minus 1 is raised to what? Half. So if you square it, these two you cancel, this should be left with minus 1. Then I raised to the power 3 will be equal to square root of minus 1 and square root of minus 1 times square root of minus 1. Remember, minus 1 times minus 1 is what? Minus 1. And square root of minus 1 is I. So minus 1 times I will leave us with minus I. Then I raised to the power 4 is square root of minus 1 times square root of minus 1 times square root of minus 1 times square root of minus 1. Minus 1 times minus 1 is what? Minus 1. This time this will give us minus 1. Minus 1 times minus 1 is going to give us 1. So you can see the possible values. So when you are given I raised to the power n, where n can be any value, a simple thing to do is to divide that value by 4. Then wherever it lands, so let's illustrate that. So what you simply do here is to do 5,234 divided by 4. 4 can go into 5 to give us 1. You take 1 over. 4 into 12 give us 3. Then you can now say 4 into 34. 4 into 34 give us what? So 4 into 34, 4 times 8, 4 times 9. Right? Let's see that. So we have gotten 4 divided by 5. That's 5 divided by 4, we have 1. Then we carry the 1. And then 4 divided by 12 gives us 3. So then we then have 0. Right? Then 4 divided by 34 going to give us 8. 4 times 8 is 32. So you carry what? 2. Remainder 2. You get it? So 1308 remainder 2. That's the value. Then how do you now answer the question? Remember we said that I is what? Square root of what? Minus 1. See that I squared is what? Minus 1, right? You see that I cube is what? You see that I cube is minus I. I will say that I4 is 1. So are you seeing it? So you will now count 2 since you remember 2. 1, 2. So where does it fall on? Minus 1. So that tells you the value. So whatever is the remainder when you divide by 4, you count from there. If the remainder is 0, that means it will take 4. So just take it like this. If the remainder is 1, to take I. If the remainder is 2, it will take minus 1. If the remainder is 3, it will take what? Minus I. And if the remainder is 0, the answer will be what? 1. So the value of I raised to power 5234 is what? Minus 1. So that is how to go about it. Let's take another one based on this. If you are giving I raised to power 476, right? What will you have? What you simply do is 476 divided by 4. 4 into 4 is 1. 4 into 7, 1 carry 3. 4 into 36 will give us what? 119. Remainder 0. So what will be the value? 1. Just like a cyclic stuff. So if the remainder is 0, that means it's the fourth one. Then if it's 1, you continue again. If the remainder is 2, it take minus 1. So assuming if we had I raised to power 477, what will it be? 4 here 1, 4 here 3. Alright, 4 into 7 is what? 1, right? 4 into 7, 1. Let me divide again. 4 into 4, 1. 4 into 7, 1. Carry 3. 4 divided 37 is 9. Remember 1. So it will take I as the value. Remember that I is the first. I square is the second. Right? I cube is the third. I4 is the, sorry, this is minus I. And I4 is 1. You will now notice that I5 will be 1 times I. Right? You see that it will the same sequence will continue again. So by dividing by 4, whatever the remainder is, you place it there. If the remainder is 1, your answer will be I. If the remainder is 2, your answer will be minus 1. If the remainder is 3, it will be minus I. And if the remainder is 4, if the remainder is 0, sorry, right, the remainder cannot be 4. If the remainder is 0, your answer will be 1. So let's take this next question now. So a complex number z is given by 2 plus I raised to power 60. Z can be represented in polar form as, so all you simply do here is that you take note of what, when they say polar form, it implies the form RE raised to power I theta. Sometimes this is not polar form, but another way of representing a complex number is R into what? Cos theta plus I sin theta, as we studied. And then another thing you should know here is the Moivre's theorem, right? Which says that a complex number z, which is equal to REI theta, which is equal to I into cos theta plus I sin theta. I sin theta. If you are not finding z raised to power n, it can be anything. To be REI theta raised to power n equal to I raised to power n into cos n theta plus I sin n theta. So I'm just giving you this cos n theta plus I sin n theta in case if it may not be in polar form, right? So we are giving 2 plus I raised to power 60. So look at what is inside, and you know how to calculate the modulus of a complex number. So what you simply do is what? 2 squared plus what? 1 squared, because the x, remember the general form is x plus yi. So in this case x is 2 and y is what? 1. We have 1i. So 2 squared is going to give us 4 plus 1, that is square root of 5. So square root of 5 is the modulus. Alright, square root of 5 is the modulus. Then what's the argument? Remember the argument is what? The angle between that complex coordinate and the x-axis. So what do you do there? You draw a line. This represents y, which is the imaginary part. This represents x, which is the real part. And then we have 2 plus I, right? So here is 2. Here is 1. They will meet at a point, right? So we are looking now for this angle here. And then you should know your SOHCAHTOA, right? So the distance from here to here is 1. Distance from here to here is what? 2. So if you are looking for theta, remember that tan theta is equal to what? Opposite over adjacent. So in this case, tan theta will be equal to 1 over 2. So theta will be equal to the tan inverse of what? 1 over 2. Do you understand? That's the principal argument. There are other values that it will take, and that can still be referred to as the arguments. So using the form REI theta, what can we say? We'll have that root 5 EI, and then theta in this case is what? Tan inverse of 1 over 2. Tan inverse of 1 over 2 is not a special angle, so we can leave it like that. Then if you now want to convert, you can use calculator. So since they are now asking us for 2 plus I raised to power 60, that means everything that is here, you will raise it to the power of what? 60. So what we will now do is root 5 raised to power 60. Remember that root 5 can be written as what? 5 raised to power what? Half. If you did what do you call it? Indexes. Fractional index. Third root of that, cube root of 5 is the same thing as 5 whole number 1. 5 raised to power 1 over 3. Fourth root of 5 can be written as 5 raised to power 1 over 4, right? So 5 raised to the power half e, then 60 times this I. You will now have 60i tan inverse of what? Half. Remember this law. Remember this law that says if you have x raised to the power y and then you have z, it will be equal to what? X raised to the power what? Yz. So that's why I multiplied what was the 60 by the I. And then to simplify this will be 5 raised to the power half times 60. Do you understand? So you have half times 60. You only have 5 raised to the power 30 e 60i tan inverse of what? 1 over 2. But if you wanted to represent it in the other way, remember that the other way is what? R raised to the power n cos n theta plus what? I sine n theta. So our R was what? Root 5. So root 5 raised to the power 60 into cos 60. Theta was what? Tan inverse of what? Half plus I sine 60 into what? Tan inverse of half. If you get it, then with 5 raised to the power 60 will give us 5 raised to the power 30 as I've explained, and then into cos 60 tan inverse of 1 over 2 plus I sine 60 tan inverse of what? 1 over 2. So that is it. If it's in polar form, you will write it in this. This will be your answer. But this is another way of representing it. You get it? Now let's take the last question. It says, what's the principal argument of 3 minus 3i? Very simple. When you're getting something like this, you should know the range of values when they're talking about principal arguments. First of all, you know that argument is the angle made by the complex coordinates and the x-axis, right? And the x-axis. So, and this complex argument, this principal argument ranges from minus pi less than theta less than pi. So if you ask for principal arguments, whatever your answer will be must be between minus pi and what? And pi. Do you understand? So you can pause the video to attempt that question. So what you simply do here is to represent the 3 minus 3i in the coordinate form so that you can understand it better to get what the accurate value is, right? To get what the accurate value is. So what you simply do is to say here is y, which is imaginary, here is x, which is the real. So we have 3 representing x and minus 3 representing y. So they are going to now meet at a point here, right? So you take from the origin down and then you are looking for what? Theta. So here is 3. The distance from here to here is what? Is also, the distance from here to here is 3. This height now is what? 3. So you have 3, 3. So you have a triangle like this. You get it. And here you are having 3. You are having what? 3 as the length. So using SOHCAHTOA, you say that tan theta is equal to what? Opposite, which is 3, and adjacent, which is 3. So theta will now be equal to the tan inverse of 1, which is what? 45 degrees. And then when you represent it in radians, is equal to what? Pi over 4. How I got it in radians is to simply do 180 divided by 45. That will give you 4. Then that's pi over 4. Because pi radians is equal to 180 degrees. But since this is on the negative side, remember that for a complex number, we are starting from this point and then we are going anti-clockwise. So this one is now going in this direction, which is a negative. Another way to calculate it, since this value was minus 3, remember it was 3 comma minus 3, you can see tan theta equal to minus 3 over 3. So your final answer for the principal argument will be what? Minus pi over 4. That's the principal argument of 3 minus 3i. Please do also subscribe to this channel, like and share this video. a standard video to explain everything for each topic on Maths 101. They are coming out soon, and I expect that you do well to watch those ones. Thanks for watching and have a nice day.